Hi, I hope you've had a really nice day so far. Okay, right, let's have a look at question 6. So we have a question that is quite a complex problem here. We've got to split it, I would say, into rectangles. Now I have all the sides given to me, so I could either cut it this way or I could cut it this way. And it depends which way you want to see it. I tend to go down, but this one, I think looking at the numbers, I'm going to go across. So I'm going to chop it this way. Now I've got two rectangles, so I'm going to label them. I'll keep the same colour. We've got rectangle 1. That wasn't very well done, was it? And rectangle 2. Maybe I'll choose two different colours, might be wise. So rectangle 1, we know that when we're working out area, we need to find the perpendicular sides. Now, I'm putting the right angle there, but actually I haven't got a side there, but I am assuming, and this is an assumption, that these are coming straight down. So I'm going to choose a right angle at the top, and I have, this is my rectangle for number 1, and it is 2 meters by 2 meters. So it's actually a square, but it looks like a rectangle because the way it's drawn. But I need to go by the information that I've been given, and that says 2 by 2, so it is a square. So I'm going to write 2 meters multiplied by 2 meters is equal to 4 meters squared. So I know that size in there, that area is 4 meters squared. I should put A equals. Now this other one, the area for this one is equal to, let's draw it. We have, now I could go with 4, but actually that's not including all of this space. That only goes up to there, doesn't it? But I do actually need all that space. So I've got to choose this length. So I have 6 meters by 1 meter. So I'm going to say 6 meters multiplied by 1 meter is equal to 6 meters squared, because they are area. They are, let's just chat through briefly. If this was 3, I could say that's 2, this is 1, and that's going to be 4, and that's going to be 5. Okay, so we've got 1, 2, 3, 4, 5, 6, and this is by 1. So I've chopped it into 6 squares, and it's 6 meters squared because there are 6 1 meter squares. So this is 1 times 1, this is 1 times 1, and we've got 1 times 1, 1 times 1, 1 times 1, 1 times 1. So we've got 1 meter squared, 2 meters squared, 3 meters squared, 4 meters squared, 5 meters squared, 6 meters squared. So the total area for this is 4 meters squared plus 6 meters squared, which equals 10 meters squared. Now the perimeter, I'd have my little person, and I've got 2 plus 2 plus 2 plus 4, 2 plus 2 plus 4, plus 1, plus 6 plus 3. Let me check. 2, 2, 4, 1, 2, 2, 4, 1, 6, 3, 6, 3. So 2 plus 2 is 4, plus 4 is 8, plus 1 is 9, plus 6 is 15, plus 3 is 18, I think, meters. And because it's a length, it's meter to the power 1 or just meters. So check 2, 4, 8, 9, 10, 11, 12, 18. Yeah. Okay. So that's the area and perimeter for question 6. Let's go to question 7. So we have, let's do perimeter first with this. So we've got 15 plus 2 plus 13 plus 5 plus 15 plus 2 plus 13, plus 5. 15, 2, 13, 5, 15, 2, 13, 5, 15, 2, 13, 5, 15, 2, okay. So the perimeter equals 15, 16, 17, 18, 19, 20, 30, 35. And because they're the same, I'm presuming the other one's 35. So I'm going to add them slightly differently. 10, 20, 30, 33, 34, 35, yeah. So the perimeter is equal to 70 meters. Let's have a look at the area. Now it's a bit more tricky how to chop this one, isn't it? We could do a rectangle there because we've got the measurements. And we could do a rectangle there. Can we do one here? So we've got rectangles 1, 2, 3. Let's just have a look at the measurements. So here I could do 5 times 15. Now can I do one here? Let's do number 3 first. That one's 5 times 13 as well, because 13 stops there, doesn't it? And here the 13 stops there. So it's not 5 times 15, it's 5 times 13. I made a mistake. I was looking at the one at the top and I made an error. So actually what I've got to do is make sure that I look at where the boundary is. Okay, so 13 stops there. Right, I'm happy with that. Okay, so what's this length then? So I know that's 2. And I know this bit is 5 here. So 5 plus 2 plus equals 7. So that must be 7 multiplied by something. But what's this length here? So from here to here is 15. And from that place to that place is 13. So that must be 2. That would make sense, wouldn't it? 15, 13, 14, 15, yeah. So I think that's 7 times 2. So 5 times 13, I think, is 65, but let's think. 5 times 10 is 50. 5 times 3 is 15. So the area there is 65 meters squared. This one is 7 times 14. 7 times, giving you the answer. You knew that anyway. 7 times 2 is 14 meters squared. And then we've got another 5 times 13, which is 65 meters squared. So let's add those up. So we've got the area is 65 meters squared plus 14 meters squared plus 65 meters squared. Right, what I'm going to do is add them up. 65 plus 65 plus, I'm going to be a bit naughty and add all three together. 2 5s are 10, 13, 14. 2 6s are 12, 13, 14. Okay, so the area of that shape altogether is 144 meters squared. Let's check because I should have checked before. Yeah. I put 18 and 10 before. Let's have a look. See if I got it right. Yes, good. Phew. Okay. Let's have a look at number 8. And then we'll have a little look at this circle stuff in a minute. So I've put here, someone built a plan of a corridor for a hospital. And they've asked us to work out the perimeter and the area. And then we're going to look at it as a volume briefly before we move on to volume. So let's have a look. We're looking for perimeter and area. Okay. Now we haven't been given all the information, have we? So I could say that the perimeter is 17 centimeters. That's the information that's given. But what I'm forgetting to do is walk all the way around the outside. And I've only been given 15 and 2. I haven't been given this 15 centimeters and this 2 centimeters. And it's not so much a trick. What they're doing is, if they ask you questions like this, if people ask you questions like this, it's for you to solve the problem. It's for you to look into it, to work out what's missing. So if you were going to walk around the outside of this space, how far have you walked? Now it's centimeters, so you won't have walked very far. I'm not even sure, I'm thinking of a length of a foot. But we've got 15 plus 2 is 17, and 15 plus 2 is 17. So that's 2 17s, which is 34. So that's 34 centimeters in length altogether. And the area is going to be the two that meet at a right angle. And we've got 2 times 15, which is 30 centimeters squared. But if that was meters, not centimeters, so let's just choose a slightly different color. If I were to draw this out and say this is 15 meters and this is 2 meters, and say it was the bottom of a corridor. So if a wall was built 3 meters high, so if there was a wall, it would probably just go straight up, wouldn't it? Like that. And then this would go like that. And this one would come up there. If we were, oh, that's gone wrong now. Like that. And then like that. And like that. So you've got a wall. And the wall here is, oh, let's use a different colour. This height here is 3 meters. So say if this was a corridor, there was a door there, you walk through the door and you walk across there and come out through another door maybe, or it's just a hallway. And the height of that wall is 3 meters. What would be the volume inside that space? And we'll be going on to volume, but the only difference is that you multiply by the height as well. So if this was 1 meter cubed, 1 meter times 1 meter times 1 meter, So it'd be 1 meter times 1 meter times 1 meter. In that case, it's 1 meters cubed because it's a cube. If that was 2, we've got 2 meters by 2 meters by 2 meters. That would be 2 times 2 is 4 times 2 is 8. That would be 8 meters cubed. And that only stays the same because it's to do with 1 by 1 by 1. So that's 8 meters cubed. So here we've got this length. We've got 15 meters multiplied by the width, which is 2 meters, multiplied by the height, which is 3 meters. And this is going to tell us how many little meter cubes there are. Meter cubes, like big things. Well, that's a meter, isn't it? You can't see my arms by meter by meter. How many meter cubes are going to be in there? 15 times 2 is 30. And that's 30 meters squared because it's 15 times 2, which is 30, and meter times meter, which is meter squared, times 3 meters. 30 times 3, 90 meters squared times meters is meters cubed, and that would be 90 meters cubed. So that's how many meter cubes would be inside that space. There'd be another up there. Oops. And there would be another one up here somewhere. Not doing very well, am I? But anyway, there. There'd be 3. 1, 2, 3. And then there would be 90 of those all together inside that space. So that's a little bit more information on area.